Hello friends, this video on Environment Chemistry Part 4 is brought to you by examfear.com. No more fear from exam. So let's understand tropospheric pollution now. So tropospheric pollution mainly occurs because of solid and gaseous particles in the air. So only solids or gaseous particles. We have solid particles here or the gaseous particles here. These are the major cause of tropospheric pollution. So if you classify gaseous pollutants, so we'll talk about oxides of sulfur which cause pollution, oxides of nitrogen, oxides of carbon, hydrogen sulfide, hydrocarbons, ozone and other oxides. These are my gaseous air pollutants. If we talk about the particulate pollutants, we'll talk about dust, mist, fumes, smoke, smog and radioactive material. So we'll talk about these many gaseous air pollutants and we'll talk about these many particulate pollutants which cause tropospheric pollution. This is a major pollution actually because we stay here and we are in direct touch with troposphere, right? So we are in direct touch with troposphere. So any kind of, and since we stay directly in touch with troposphere and we the human has spoiled this nature, so the troposphere is the one which has got maximum impact, right? So you see a lot of oxides of sulfur, carbon, nitrogens, and we have dust, smoke, smog, everything in this particular part of atmosphere. So we'll study these things in detail now. So let's start with the oxides of sulfur, that is nothing but one of the gaseous air pollutants. So we talk about the oxides of sulfur. There are so many oxides of sulfur. The most deadly and the most common oxides of sulfur are SO2 and SO3. These are my two most deadly and most common oxides of sulfur, right? Sulfur dioxide and sulfur trioxide, and they're the most harmful ones. And if you see, most of the sulfur dioxide, it comes from volcanic eruption. And the rest is from volcanic eruption. It's almost 67%. And the rest is when you burn fossil fuels which has sulfur in it, almost 33%. Correct. And as I told, as I have already also explained, this my SO2 is my primary pollutant and SO3 is my secondary pollutant, right? So you generally get SO3 from SO2. So the typical reaction is from SO2. It reacts with oxygen, you get SO3, but this reaction is generally slow. This reaction is slow if it is done without any catalyst. But generally in atmosphere we have moisture, right? So with also other pollutant in the atmosphere that act as a catalyst, and this reaction becomes fast. Correct. So because of other pollution in the air, this becomes fast, and then this SO3 when reacts with water, moisture, it becomes H2SO4, that is my sulfuric acid, and then it comes down to earth in forms of acid rain. We'll discuss acid rain and we'll see that where sulfuric acid when it reacts with water, it forms sulfuric acid, and sulfur trioxide when reacts with water, it forms sulfuric acid, and this is what you get in acid rain. Right? Now we talked about oxides of sulfur. We talked about sulfur oxide as the primary pollutant, and then sulfur trioxide is secondary pollutant, and which is generally created when sulfur oxide reacts with oxygen in presence of other pollutants in the atmosphere. Now what are the effects of sulfur? The first is that even at low concentration, right, it causes respiratory disease such as asthma, bronchitis. These are the diseases that you get in human because of sulfur. So when you say sulfur, for SO2 the threshold limit is what? It is 2 into 10 to the power minus 4 ppm. This is the threshold limit. So if it exceeds this, it is a problem. And even at low concentration, it has tendency to form asthma and bronchitis. Sulfur dioxide also causes irritation in the eyes. That makes this eye red and you get tears also. right? High concentration of sulfur oxide also leads to stiffness of the flower buds, and with this the flowers eventually fall off from the plants. It also produces corrosive effect on the building materials. Building materials which are of marble, and the reaction is my marble. For example, if it is limestone or marble, I have this CaCO3 limestone, and it reacts with H2SO4. There is nothing but sulfur dioxide in the form of acid rain, because that sulfur trioxide actually explain the sulfur dioxide plus water gives H2SO4, right? So this comes and this reacts with this, so you get CaSO4 and water and carbon dioxide. So these buildings are corroded because of sulfur. It also causes decoloration of fabrics, paper, leather. So all these get decolorized because of sulfur. So these are my effects of sulfur, right? So you get asthma, bronchitis, redness in eyes, the flower falls easily, the building corrodes, the paint deteriorates. Now we'll talk about where is the sink of sulfur, right? I told that sulfur is produced 67% from volcano. So there has to be some sink for sulfur. So generally the oxides of sulfur are converted to sulfuric acid, and then it combines to limestone materials. Example, if there is some sulfur gas here, SO2, this will actually react with this marble stones, and this marble stone will consume the sulfur. Same reaction as I told, CaCO3 will react with H2SO4 and it will form CaSO4 and water and carbon dioxide. So this will be my reaction. So my calcium carbonate or my limestones, marbles, they are my natural sink for sulfur. Now we'll talk about nitrogen, oxides of nitrogen. So if you see, there are so many oxides of nitrogen. You talk about nitrogen dioxide, nitric oxide, nitrous oxide, right? Then nitrogen oxide, NO3, N2O3, N2O4. There are so many oxides of nitrogen. If I write here, I have NO2, I have NO, I have N2O, I have N4O, I have NO3, I have N2O3. There are so many oxides. N2O4, N2O5. There are so many oxides of nitrogen. But out of these, the one which is notorious is, and I mean other are also notorious, but the one which are in abundant or which cause more problems to us now currently is NO and NO2. Correct? Nitrogen dioxide and nitric oxide. So if you see how they are formed, see nitrogen, and as I told, nitrogen and oxygens, they are major constituent of atmosphere. So if you see, 78% of the atmosphere is nitrogen, oxygen is almost 21%, and the remaining 1% almost is other gases. So if you see, the major chunk is nitrogen and oxygen, correct? Though they are abundantly there in the atmosphere, almost if you see 79% and 21%, but they don't react. These guys, they don't react with each other at normal temperature. But at high altitude, when there is a lightning strike, these nitrogen and oxygen combine to form NO2. Correct? So I have nitrogen, dinitrogen, I have dioxygen in ample amount in the atmosphere, but they don't react to form oxides. So how it is formed then? In the lightning strike at high altitude, nitrogen and oxygen combine to form nitrogen oxides or nitrogen. Nitrogen dioxide is also produced in soils by microbiological process. There are some microorganisms here. They also form nitrogen dioxide. In the automobile engine, when the fossil fuels are burned, this nitrogen and dioxygen, this N2 and O2, they combine to form this nitric oxides and nitrogen dioxide. So these automobiles also emit nitric oxide and nitrogen dioxide. There are certain industries which produce nitric acids and sulfuric acids. So in those acids also you have oxides of nitrogen as byproduct. So if you see, out of 4 sources, 2 are my natural, one is the soil, the other is the lightning, and 2 are my man-made. So if you see sources, in the earlier example also I told you sulfur dioxide 67% comes from the natural source, that is volcano. Here also if you see, a good portion comes from the natural source and the good portion comes from the source created by human. Now we'll see what are the effects of nitrogen in human being. See, the first major disadvantage or impact of nitrogen is, we have seen the carbon monoxide, it combines with hemoglobin and forms a complex compound, very stable, and that decreases the oxygen transport facility in the blood, efficiency of the blood. Similarly, nitrogen, this guy, nitric oxide, also combines with hemoglobin and decreases the oxygen transport capability of the blood. That is the first major disadvantage or effect of nitrogen, oxides of nitrogen. The next is, if you see the red color haze here, right? This is a city and you see the red color haze. This is all because of dioxides of nitrogen, that is NO2. Because of NO2, this red color haze is there. And this is irritant actually. It will create redness in the eye. Also, higher concentration of NO2 will damage the leaves of the plant and will retard the photosynthesis process. The plant won't grow. The plants in the trees won't grow because of higher concentration of nitrogen dioxide. Nitrogen dioxide can also impact the lung. It can impact your respiratory system. Right? It can lead to acute respiratory disease. So nitrogen dioxide is really harmful to us. It can also decolorize textiles fibers. It's harmful to textiles and fibers and metals also. So you see the harmful effects of oxides of nitrogen. The first, the critical one is it combines with hemoglobin and it will decrease the transport efficiency of blood. The next is it can cause redness in the eye. It can cover the whole city with the red dust. Right? It can retard the growth of trees. It can create or impact your respiratory system, and it also impacts the textiles and metals. So what is the sink of nitrogen? So it's mainly natural process. This is mainly natural process that acts as a sink. So what happens is I have NO2, right? So it will react with water and oxygen. It forms nitric acid. If you want, you can write the balanced reaction. This is 2 here, this is 4. Or if I have NO, it will react with oxygen to form NO. So these are my sink, because in both cases we are consuming oxides of nitrogen. Correct? So these are my sinks for nitrogen, because if you see, the natural process creates a good amount of nitrogen, so there has to be a natural process which takes away nitrogen from the environment. We'll talk about hydrocarbon, that is also a gaseous air pollutant. As you've understood this in the hydrocarbon chapter, where we say that hydrocarbon is nothing but they have only carbon and hydrogen, and they are formed by incomplete combustion of fuel in the automobiles. You've also studied in the last chapter that they are carcinogenic because they cause cancer. They were risky. We have told that benzene, right? Benzene rings, if you have 2 or 3 complex benzene rings like this, so all these compounds are carcinogenic. And they also harm the trees because it causes aging in the trees and break down tissue of the trees, shading of the leaves, flower. Trees actually die early. They don't grow because of hydrocarbons. Now we'll talk about carbon monoxide. Carbon monoxide is colorless, odorless, and poisonous gas. It is also because of incomplete combustion of carbon. So carbon in the presence of very small oxygen, very small amount of oxygen, you get carbon monoxide. Right? If you have in very small amount of oxygen, not sufficient, you get carbon monoxide. It's colorless, odorless, and poisonous gas. It is generally produced from forest fire. This is my forest fire, or from volcanic activity also. Right? This is my carbon monoxide. It is also formed by bacterial decay of organic matter. Correct? So this bacterial decay also forms carbon monoxide, and the concentration that is allowed as maximum is 10 to the power minus 4 part per million. So if I have 10 to the power minus 4 carbon monoxide part per million, it's okay, else it is harmful. Right? It is also released into air by automobile exhaust, because sometimes the combustion of the fuel doesn't happen properly and you get carbon monoxide here. It is also formed by incomplete combustion of coal, firewood, petrol, etc. Because they told if there is an incomplete combustion of carbon in presence of oxygen, you get carbon monoxide. Correct? It is also produced in the industry where you react carbon at high temperature. There also you get carbon monoxide. So these are various sources of carbon monoxide. Right? It can be from volcanic activity, forest fire, the bacterial decay here, the combustion by automobiles, or directly when you burn coal, firewood, petrol, or from the factory. Now what is the impact of carbon monoxide? As I told, the first one is that carbon monoxide combines with hemoglobin to form complex compound that is very stable, and that decreases the oxygen transport efficiency of the blood. So if you see, it binds with hemoglobin, it forms carboxyhemoglobin, which is very stable. And this impacts the oxygen transport efficiency of the blood. Correct? So in the blood, if the concentration of carboxyhemoglobin is about 3 to 4% also, the carbon capacity of carbon carrying capacity of the blood is reduced. So carbon carrying the oxygen carrying capacity. This blood carries oxygen. So if you have more concentration of carboxyhemoglobin, that is nothing but carbon plus hemoglobin, the oxygen carrying capacity of the blood is greatly impacted. And this leads to headache, weak eyesight, nervousness, and cardiovascular disorder, and sometimes even death also. This is the reason we ask people not to smoke, because when you smoke, you get carbon monoxide also. Correct? And this is strictly prohibited for pregnant women, because it can cause premature birth or abortions or deformed babies also. So smoking is totally prohibited for pregnant women. Correct? As I told, the maximum possible concentration of CO is 40 part per million. Yeah, it is 40 part per million also. I think in the previous slide I told it's 10 to the power minus 4 part per million. That's wrong. It's 40 part per million. So what is the sink of carbon monoxide? I told carbon monoxide is also from a natural process, volcano or something. So there has to be a sink for carbon monoxide. So soil is a major sink for carbon monoxide. These are microorganisms which are there in the soil. They remove carbon monoxide from the atmosphere. Right? Also, there are species in atmosphere, for example, hydroxyl, oxygen, ozone. They help convert carbon monoxide to carbon dioxide. Right? Carbon dioxide is also harmful, but not as harmful as carbon monoxide. Right? Carbon dioxide is a little less harmful. It causes global warming or something, but it can easily be consumed by trees then, right? The plants, trees, they take carbon monoxide and gives oxygen. So in that way, carbon monoxide can be consumed. So carbon monoxide converts into carbon dioxide in presence of hydroxyl, oxygen, or ozone in the atmosphere, and then carbon monoxide is removed from the environment by trees. Let's talk about carbon dioxide. Carbon dioxide is released by humans generally and all the other animals also by the process called respiration. Using respiration we release carbon dioxide into atmosphere. Also, when you burn a fossil fuel you get carbon dioxide here. Mostly carbon dioxide, some amount of carbon monoxide if you don't burn in proper in the presence of oxygen. It is also produced while decomposition of limestone during manufacture of cement. When you manufacture cement, a lot of carbon dioxide is emitted during manufacturing process of cement. Also, volcanic eruption, you get carbon dioxide. Also for the biological decay of plants. So if this plant dies and it decays, you get carbon dioxide there also. So what is the effect of carbon dioxide? So the major effect of carbon dioxide is global warming. You must have seen this thing in the news that carbon dioxide is increasing, you plant more trees, it's causing global warming. So we'll talk about global warming, what is global warming and how carbon dioxide is responsible for global warming. But before we talk about this, let's understand some of the basic thing that carbon dioxide is confined only in troposphere. This is my troposphere. Right, this is my troposphere. So my carbon dioxide is only in this zone. Correct? So here I told I have nitrogen, oxygen, all these things are in stratosphere. But in troposphere I have only, the carbon dioxide is there only in troposphere. There is no carbon dioxide here. It is not there. Correct? Also, it is only 0.03% by volume in atmosphere. Very small amount, 0.03% by volume in atmosphere. So after this slide, in fact one more slide, will talk about the global warming and the role of carbon dioxide. But before that, let's understand what is the sink of carbon dioxide. Ocean is the major sink of carbon dioxide. Ocean dissolves maximum carbon dioxide and forms carbonates. Right? The next sink is green plants. Green plants also removes carbon dioxide from the nature. So let's thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.